Hi.
Hello. Hello, good afternoon. Hello, Sunday, can you hear me? Hello.
We can hear you. Are you driving?
How do you know, sir? Yes. Sunday. Hello, gentlemen. Good afternoon. Once again, I want to welcome us to the final session of this training. I have received several requests from participants about the videos and everything. By the end of this training, the video was not recorded on the cloud, unfortunately. It was recorded on a system, so we need to find a way to upload it on YouTube and then share the link, because sending it directly to us will be so heavy and so massive. So please, for those who have not gotten the video, please, this is an apology. I apologize that the material has not got the video have not gotten to us. Then for the material, I will advise that I will send the link on the Google Drive, so we can log in on the Google Drive and download them. I think that's the best way to send these materials. Then I think that is that. Then let's give a grace period of 3 minutes. We'll start by 15 minutes after 3, so that so far about half of us are available. Let's just give them that 3 minutes grace, which is total of 15 minutes, and let's see whether they can join us. We are 20 now, so we're waiting for the remaining 8, 9, 10%. So please, I crave our indulgence to exercise patience. Will soon kickstart. Sunday is already around. Hello, Engineer Sunday.
Yes, I can hear you. I'm here.
Okay. In 2 minutes time, we can start in 2 minutes time.
Yes.
So,
At least by 5:15.
Yeah, by 5:15 we'll start.
You start.
Yes, so that's it. So can you talk more about on the video while we're waiting for others? Hello, Sunday.
Who is that? Hello, can you see my screen?
Yes, I can see your screen.
Okay. Please, maybe the next 2 minutes, I'm starting the program. So just let me adjust my speaker and other things. In the next 2 minutes, we will start. I'm coming up now. Thank you. Okay. Hello, guys. Can you see my screen? Hello, can you see my screen?
Yes.
Yeah, I can see it.
Yes, I can see your screen.
Okay, just a minute. Let me connect my headpiece. I think. Okay, today we are going to start from where we ended yesterday, where we stopped yesterday. And yesterday we discussed a lot of things yesterday, and there is I think there is an assignment I gave to you people yesterday, but maybe at the end of the program we'll see how we can solve that together. But meanwhile, I want to share my screen again. I'm trying. Can you hear me? I'm trying to connect my headpiece.
Sir, you are very loud.
Okay, but I'm trying to connect my earpiece. It's like I'm
We're hearing
hearing
you.
from my computer.
Okay.
Okay, just my I'm hearing you. I'm hearing you people from the computer. I want to connect you to my earpiece. I don't know why it's not connected to me. It's not connected for me. So let me try again. Okay, so let me start to record. I don't know what.
Okay, I'm recording now. So all what we have been discussing over time is all financial cost engineering, where we talk about a lot of things, and specifically yesterday, we talked about payment, principal, interest, when interest is to be specific for a specific duration. Then we went further to discuss what if analysis, where we use a goal seek, where we use scenario manager, and where we use data table. We went further to discuss sensitivity analysis, where we discuss reduce cost for variable share and for shadow price for constraint. And we said that the shadow price is the marginal cost, while the reduced cost is the opportunity cost. And we went further to use Excel solver to optimize a certain problem yesterday, and we discussed the objective function, we discussed the variable share, and we discussed the constraint, and we discussed 3 types of algorithm for solving optimization, which is the linear programming, which is the generalized reduced gradient, and which is the evolutionary methods. So I hope everybody can hear me. I think there's somebody say, I can't hear you.
We can hear you, sir. Please go on, we can hear you.
Okay, fine. So today's course is we just limited to project cost engineering, and that is where most of you will be interested in, and that is what most of you will be interested in today, because most of you are into projects, into construction, and you want to know how to do basic of estimates and how to specifically how to control costs on a project, whether EPC project, whether engineering project, and any other project. So I will share my screen. I think my screen is already on share. Okay. Now, today we are talking about project cost management. In project cost management, there are 4 steps you need to follow, and they should be in sequential order. The first is project cost planning. The second is the project cost estimation. The third is the project cost budgeting. And the fourth is the project cost scheduling and control. And they must follow that order. It's very common in CCP exam and even in project management exam. It will ask you, in project cost management, which of the following is the correct sequence? It must be project cost planning, must be cost estimation, it must be cost budgeting, and it will be cost scheduling and control. Now, when we talk about cost planning, in ideal life, during project initiation, you bring out the business case for that business, you bring out a high level absorption, a high level constraint, the purpose of the business, why you want to venture into the business. You will bring out all those concepts and put it out during project initiation. And at that point, you will want to see how are we going to really carry out this project. That is planning stage. Now, there are 3 levels of planning. So also we have 3 levels of estimating. The levels are level 1 planning, level 2 planning, and level 3 planning. Level 1 planning is the conceptual and preliminary planning. At this stage, you just give a high level planning. Okay, we assume this, let's do this, because we are just guessing as at that point. There is no basic information about the project. There is no detailed design about the project. There is no specification about the project, but everything is just based on past experience. That is the type of level planning we call level 1. It's called conceptual or preliminary planning. And but the accuracy of that planning is between -30 to +60%. So that is 30% less accurate or is 60% more accurate. The next level of planning is level 2 planning. At this point, you have plans, you have specification, but there is no detailed engineering design. The variation at this level is also -15 to +20. It's either is -15 less accurate or +20 more accurate. That is within range. That is why estimate is within range. Estimate is must always be in a range. There is no two estimators or 2 QS who will carry out an estimate and they will arrive at a particular answer. No. Or the same answer. No. The estimates must be within range. But when the range is within validation range, which is at least ±10% for model validation or data validation, then you are good to go with that estimate. The other type of estimate is definitive estimate. At this point, you have the design. It's a combination of all the information for the conceptual design and all the information from the engineering design. So you combine them up, you will be able to come up with a more definitive planning, and that is called the level 3 planning. And the accuracy of that planning is between -3 to +5. Just give me a minute. Let me talk to this. There's a noise in my background. Sorry, I quickly stop the noise in my background. So that is planning. Why is planning important in cost engineering? After project initiation, when you now enter, there are almost like 5 stages of project management: project initiation, project planning, project execution, project monitoring and control, and project closure. We'll come into that later when we'll be discussing about progress measurement and performance evaluation. Now, planning is important is that most of the projects we involve ourselves in lack some basic information about planning. And planning is very, very, very much important. There is a project we involve in, and because we fail to plan, we end up in failure. Now, what I'm trying to tell you is that at the planning stage, there are 2 important key words you must put into your contract document that will guide you in the future. Otherwise, you will run into problem. That is what we call cost escalation and cost inflation. Cost escalation and cost inflation, they are 2 different things. And if you fail to embed them into your contract term, there is a likelihood that you are going to run into problem in the future. Then what is escalation? Cost escalation can be a material escalation, it can be a labor escalation. When the price of a particular material increases over a period of time, it is called material escalation. When the price of a labor increases over a period of time, it is called labor escalation. For example, a mason that is receiving 1,500 naira today, within a period of 1 year, the price changes to 2,500. That sharp increase in the cost of that labor is what we call labor escalation. If, for example, within the construction period, a bag of cement is 2,500, but all of a sudden the price jumped to like 3,000, that is called material escalation. It's specific to either material or the labor. And when it happens, how will you now factor that into your contract? If you are being given a contract that will run for a period of 3 years, and immediately you start, after 1 year, there is a material escalation, there is a labor escalation, how are you going to resolve that issue? That is why most of the contractors will run away from site, they will abandon their project, because there is no escalation clause, there is no material or labor escalation clause. At the preliminary stage, during the planning stage, you will agree with your clients that please, I'm entering into this contract with you for a period of 3 years. But if, peradventure, within this duration, within these 3 years, there is a material, the price of bag of cement exceed 10% increase, or the price of labor exceed 10% increase, I will not be able to continue with this project. In such a case, I will come back, then we review the contract term and see how you can control that escalation. But when it is not embedded, there is a likelihood that that project must fail. And that is what, this is one of our projects we were involved in before I come into the project. The project was supposed to build a house, deliver the house to the subscriber for a period of 3 years. Immediately we start the project, inflation hit the market. And we are purchasing material, the value of dollar increased, and we were running up hectare. After 5 years, we were still unable to deliver the house to those clients. And there are some clients who already agree with us that within 3 years, they will be landlords in their various houses. But unfortunately, within that 3 years, we could not deliver those buildings to them. And some of them sued the company to court, and the company was not paying their house rent in where they are, pending when the building will be ready for use. So, but if they have embedded those escalation clauses, and if material escalation clause and labor escalation clause into the contract term, they will be able to go back to the client. Please, we can't continue again. We have to review this contract term. The difference between escalation and inflation is that while inflation affects the general economy, escalation affects only specific section of the economy. For example, the material section, bag of cement. The labor section, the price of machine. So when the inflation is related to the economic generally, it is called inflation. And that is why to measure inflation, we have to use what we call basket of inflation. A basket of inflation is a basket that consists of up to 1,000 commodities. You will check their various price changes over time. By the time you relate all the price changes of all the 1,000 goods, you will be able to come up with a specific unit price. And that change in price is what we now relate to the economic as inflation. If you read financial newspaper, you will be seeing the inflation rate of the economic, maybe weekly or as time goes on. So that is the difference between cost escalation and inflation. They are different. Now, let's go. I've just discussed all this. I've discussed this. Now, let's go to the next thing. We are through with the planning. Then let's go to estimating. The next section, the next aspect of it is cost estimates. Estimating is nothing than looking at the quantities and looking at the price. Please remind me after this training for me to send you a site where you can be getting the price list of all the material you need in construction every day. The site is always updated every day. If you need the price of cement, the price of iron, you need the price of this, just go to the site, you will get all the prices. It's always updated every day. Just remind me at the end of the training, I will share the link with you. Now, estimating is nothing other than looking for the quantity and bringing out the corresponding prices. We all involved in estimating in one way or the other. Even right from our university period, if we want to purchase our lecture material for any of the semester, we begin to bring maybe Civil 121 so price, Civil 311 so price, Civil this so price. You are already estimating. Estimating is try to get the quantity and bring in their corresponding prices, then you get the total cost, which is now price times quantity. But there is one thing you should know: you must be able to know the unit of what you are working with. Unit is very important. Sure, we use volume. In lab, we use area. You use length. All those units, you must be familiar with them. And also, you must understand the technical term used in reporting in estimates. You must understand the concept that is in this BMS4. Building engineering, building and engineering standard method of measurement, volume 4. I think we should also have a civil engineering standard method of measurement, volume 5. Maybe at the end of this training, we will share them also. If you don't have it, I think we have shared BMS4. So all those technical terms you have the say in BOQ, maybe they will say excavation in foundation, not exceeding 1 meter depth. All those terms are already in this BMS4 or CMS4. Knowing the unit price rate is also very important. That is why you must understand the price book. Price list is location based. The price of material in Lagos is not the same in Abuja, it's not the same in Port Harcourt. When you are using price list, you must consider the location where you are working with. It's location based. The BMS4 has not been shared. I think some have, but we share for the other people. Now, these are standard methods of measurement. We have volume, you can have the length and its breadth and its height. We have areas, we have length. You all are all familiar with this. But this is an example of BMS4. These are description when you are trying to prepare a BOQ. I think my colleague Uche can give you permission to record. Uche, please give them permission to record. Some are demanding for recording. Though we are recording it, we share everything by tomorrow. So all those terms you are seeing here, they are putting under this description. All these terms are already in BMS4. You just to put them and put it here and note the various clauses. Now, one important thing you need to know in estimating is material takeoff and measurement book. You, as an estimator, you must have a measurement book. You must be able to take off material. Try to extract quantity from a drawing is what we call material takeoff. And you must have a material takeoff sheet that can help you to do what you are doing. This is an example of material takeoff sheet. You must have this sheet when you want to become an estimator. Here we have the company, we have the project, you have the address, you have the job, you have the estimator who's estimating it, who check it, due date. Then you will now come here. For example, if you want to look for foundation, excavation in foundation, you will put it here. Then the length of the excavation, you put it. The width, you put it. The depth, you put it. Automatically, the quantity and the volume will drop out for you. Is this material takeoff sheet that is used by estimator or by a quantity surveyor to extract the BOQ. This document is different from BOQ in the sense that BOQ is just quantity and the price, and you get your total. But whenever you have a problem with your BOQ, you can easily come back to your takeoff sheet and you know where the problem lies. This is an example of BOQ. In BOQ, you can have the quantity, you have the unit rate, you have the unit of measurement, you have the rate, then you have the amount. But this document is being prepared from this material takeoff sheet. If you don't have this material takeoff sheet in the same place, by the time you have error, you want to clarify. Here you just say quantity is 7. What makes up this 7 cubic meter? You must know the length, you must know the width, and you must know the depth. It's the material takeoff sheet that will give you those information. After this, we will go back to Excel sheet. I will teach you today how we have some civil engineers, we have mechanical, we have electrical, but I will give you a little basic understanding of how you can estimate the quantity of material needed in your building, maybe the numbers of bag of cement, the numbers of cement, bag of cement, the numbers of the tonnage of reinforcement, the tonnage of sand, and the tonnage of gravel you need. And we'll see how you can calculate reinforcement detailing in your construction work. Just for basic knowledge, in case you want to build your house and somebody want to cheat you, you tell them, I know what I'm doing. Now, we now come to cost estimating. In cost estimation, we have different types of estimates. We also have the conceptual and the preliminary estimate. The conceptual and the preliminary estimate is an estimate you give to the owner because there is a limited information about the project. Somebody will just meet you, please, I want to build a 4 flat in Lekki. What is the estimate of building the 4 flat? Because you are familiar with the terrain, without drawing, without anything, you can just tell the person, I think it's 80 million naira. That is conceptual estimate. And that is done at the level of level 1 planning. But the problem is that it's not always accurate. The other one is detailed estimate. The detailed estimate is the estimate you carry out when you now have the specifications and the plan. The plan is being given to you. The specification is being given to you. Please use 12 mm reinforcement. Use concrete strength of 20 Newton per square mm. So all those things are being given to you. Based on that, you can now narrow down your estimate to a detailed estimate. The level of accuracy is -15 to +20. Then the most accurate estimate is what we call the definitive estimate. This is the type of estimate that is being related to the work breakdown structure. that you break down your activity to the lowest level of work breakdown structure, and you begin to assign costs to each of the activity, and at the end of the day, you roll them up, then you get a specific amount. For example, this is the type of definitive estimate. You break down all the activity to the lowest level. These are activities. Activities is the lowest level of work breakdown structure. Work breakdown structure, which is WBS, is the breaking down of activity. Maybe it can be either in the summary level, like excavation of earthwork. It's a work package, work breakdown structure. But when you try to break them down to the lowest level of each activity, they now become work package, which is all these ones are work package, and work package add together to give you work breakdown structure. So by the time you are giving it their corresponding prices, you can see at this point, excavate stretch for coverage, commencing from ground level and not exceeding 1 meter depth. The quantity is this, the rate is this. Try to assign cost to that activity is what we call cost breakdown structure. But breaking down the activity to this level is what we call work breakdown structure. But if you are assigning human being that will carry out this task, say, John will do this work, that is what we call resources breakdown structure. When there is a risk inherent in this project, and we know that the risk will happen, then we can call it the risk breakdown structure. So we have work breakdown structure, we have risk breakdown structure, we have resources breakdown structure, and we have a cost breakdown structure. Now, there are different methods of estimating. That is what will be very important to you and is common in CCP exam and project management exam. One of the methods of estimating is what we call analogous estimate, or called top-down. An estimator, and I will ask you, please, I want to build a house in Lekki, and it's going to be bungalow. How much will it cost me? There is no drawing, there is no specification, there is no plan. Please give me an average range. Because you are familiar with the terrain, what you just need to do is just to look up like this. You just look up and say, okay, I think, anyway, I think 50 million can do it. That is why it's called top down. You look up and you look down, you give the estimate. It is used when there is no drawing, there is no specification, there is no plan. And you use your expert knowledge to give those information based on historical information. The advantage is that it's very quick, but it is less accurate. The other one is the bottom estimate. The bottom estimate is the one I showed you just now when we are doing the work breakdown structure. People doing this work is base their estimate on the work breakdown structure. You begin to assign costs to each of the activities. If I want to paint a wall, I will break down the activity into, okay, cost of paint, cost of transportation, cost of machine, cost of all those things. By the time you now sum all of them up, you are going to come up with a specific amount. That amount is what will be the estimate. And the method of doing that is called bottom-up estimating. It is very accurate, but it's very slow and tedious. For you to be breaking down all your activity to the lowest level of work breakdown structure is going to be very cumbersome and very time-consuming, but it gives you the most accurate estimate, and it is also the estimate that we use in control accounts during project scheduling and control. We'll come to that shortly. The other aspect is the parametric estimate. The parametric estimate uses mathematical or statistical model to develop a relationship between variables. For example, you want to build a house, you know the square areas, and you know the various costs you have been using. In such a case, you have to develop a model, a regression model. Such a regression model will help you to forecast the likely amount of the building of the cost of the building. I think I will show you an example of parametric estimating shortly using a regression model. Under this parametric estimating, we have what we call the regression analysis, which I will show to you, and we have what we call the learning curve. The learning curve shows that the more experienced you are on a project, the more accurate the estimate will be. That is what the learning curve is telling you. You learn from experience. The other type of estimate is what we call the 3-point estimating. This 3-point estimating is based on uncertainty, because there are inherent uncertainties or risks in your estimate. You have to put them in a range. We have the worst case scenario, which is the pessimistic estimate. We have the optimistic, the best case scenario, which is the optimistic, and we have the most likely, which is the base case. Like yesterday, when we are developing a scenario for scenario managers, I was using yesterday worst case scenario, best case scenario, and base case scenario. That is an example of 3-point estimating. So in these scenarios, we have the worst case, which is the pessimistic estimate. It shows that assuming everything goes wrong. The optimistic is the best case scenario, assuming everything goes on well. Most likely estimate, assuming everything goes midway. It shows that if you have those 3 conceptual estimates, you will be able to use 3-point estimate to come at a mid-level. That is when you have uncertainty in your estimate. For example, during one of this training in Lagos, we were deliberating, and I asked most of the participants, if you want to build a 4 flat in Lagos mainland, how much will it cost you? One of the participants said it's going to be like 45 million. Then one of the participants said, 45 million is too much. I think 30 million can do it. I mean 25 million. Then another person responded, even though 45 million is too high, 25 million is too small. To him, he thinks 30 million can do it. That is 3-point parametric estimating. The 45 million is the worst case scenario, pessimistic. The 25 million is the best case scenario, optimistic. While the 30 million is the most likely estimate, which is the midway. When you have them, you cannot use this formula to get the likely estimate for that situation. The formula is optimistic plus 4 most likely plus pessimistic, everything divided by 6. In this type of estimate, you use this formula. We have 2. The first one is called the Becker distribution. You use this distribution for the estimate when you have some historical information about the project. In such a case, the weight of the estimate is being aligned to the most likely. You can see that this most likely is carrying a coefficient of 4. It means that more weight is being given to the most likely. So, but when you don't have historical information about the project, you use the triangular distribution, which is a normal average. Optimistic plus most likely plus pessimistic, everything divided by 3. It's very common in project management exam. They will give the formula, they will ask you under which condition will you use any of them. We use the number 1 when you have historical information about the project. You use the second formula when there is no historical information about the project. And when you finish, because an estimate is always a range, there is likelihood that there will be variance. So that variance, you can estimate it from this standard deviation, pessimistic minus optimistic divided by 6. When you have the standard deviation, and I think the square root of variance is standard deviation. So when you square your standard deviation, you have your variance. That will show you the likely variance from the actual of your estimates. Now, we can also have all those ones, but they are not common like that. Now, the next thing we will now talk about determine budgets. After the determine budget, I will show you some estimated principle in Excel sheet. Now, just now I told you we have cost in cost management. We have cost planning, number 1, which we have discussed. We have cost estimating, which we just finished, and we have the next is cost budgeting. Budgeting is different from estimates. Estimate is the cost of all the activities that makes up your work breakdown structure or your work package. You assign their corresponding prices to it. Now, there are two terms I will show you today, we have what we call contingency reserve and we have what we call management reserve. And most of you must be familiar with contingency. And you don't know why it's always there in your estimate, 5% contingency. Why? How do they know that the 5% will be enough to react with the contingency when it happens? So there are two types of contingency. Contingency is called reserve. There are two types of contingency. We have the contingency reserve and we have management reserve. If you want to start your project construction work, the first thing you need to do when you now come on with the scope of work, you have to come on with what we call risk registers. A risk register is a document. Maybe I will show you a risk register shortly. I think I've sent a risk register to some of you. A risk register is a document that itemizes all the inherent risks in the project and you put in their various control measures, the action plan in case they happen, how you are going to tackle with the risk. These risks are of two types. You may know them, you may not know them. Risk that you can identify on a project, which you know, is what we call contingency reserve. It's also called in the simple term, know or know. In project management exam or CCP, they may bring it out as know or know, not contingency reserve. So contingency reserve is also known as know or know. This or know is the risk, which is the uncertainty. You don't know it. But contingency now means you know the risk. You know it. A risk that you know that there is a likelihood that they will happen on a project is what we call contingency reserve. And they are normally within a 5 to 10% of the project cost. But when you add the contingency reserve plus the cost estimate, you are going to have what we call the cost baseline. Cost estimate plus contingency reserve is what we call cost baseline. And it's this cost baseline that we use in benchmarking. It's what we use in scheduling. It's what we use in cost control. Now, the next reserve is what we call the management reserve. In as much that we know that there are some risks that are inherently known on the project, there are risks that we cannot determine as at the point of construction. They are called the act of God. They can happen unexpectedly. For example, the COVID-19 that happened this year. Nobody ever expected COVID-19 to happen. So it happened, and everybody were running up and down. Government, because there is no management reserve to tackle up the COVID-19 issue, Nigeria begin to borrow from foreign countries. But there are other countries that has reserve that they pull it out to quickly handle that risk. So the money you reserve to handle risks that are not known is called management reserve. The risk, the money you set aside to handle risks that are known is called contingency reserve. So the management reserve, which is unknown risk, is also called unknown or no. Unknown is the reserve, is the contingency, but you don't know it. This contingency, you know the risk. Management, you don't know the risk. So by the time you add cost estimate plus contingency reserve plus management reserve, you have what we call budget. It's because most of the people are not taking into account this management reserve, that is where most of the projects are failing. It's like a man, his wife is pregnant. The man is proposing, oh, okay, there is a likelihood that my wife might deliver twins. Fine. The man will make a preparation for that baby twins for 2 kids. But in the point of delivery, unfortunately enough, the woman will, the doctor will say the woman is going to deliver through CS, through operation. And because the man failed to put a reserve, in what of if my wife delivers through operation, where will I see the money? So if a man fails to put that reserve in place and eventually the woman wants to deliver through operation, that is when you see this. They will say some husband run away from hospital because they cannot cope with the situation. We have a friend recently, his wife was pregnant. He was looking for money, at least a normal delivery cost to take care of the wife because he's not working. Then we are trying to see how we can help you to raise some money. But unfortunately, in the case of the labor, the doctor announced that the woman can't deliver on her own. It's going to be through operation. So the guy almost ran mad because he was thinking of how to pay for the one that he knew, but unexpectedly, on no risk, come in. So the money you reserve to tackle on no risk is what we call management reserve. And the one you reserve to tackle the one you know is called contingency reserve. By the time you add estimate cost for contingency reserve, for management reserve, then you come up with what we call budget. That is the difference between budget and estimate cost. But there is difference between budget and cost baseline also. In cost baseline, we don't include management reserve. It's only estimate cost plus contingency reserve. And that is what we use in baselining. Note that the contingency reserve money is not a contractor's money. It's a money you just keep aside in case the risk happens. You are going to use that money to react to the risk. The next one is now project cost control. And in project cost control, I will get with that in a separate material. So at this point, we will see how to calculate basic material that makes up a concrete in building. At this point, I will give you 3 minutes, 4 minutes, you come back 4:10. Then we enter into our Excel sheet to carry out basic estimates before we enter the cost control. Thank you very much.
Okay, thank you, Engineer Sunday. Hello, Engineer Sunday.
Yeah, I can hear you.
Okay, okay, maybe okay, of course they have the material, so let it be as you said in 4 minutes. They have the material, they have the cost practice sheet, they have it estimating. Please, if you don't have it, you might indicate. Go ahead, sir.
Yes, I have about 2 Excel sheets there, or 3. Which of them is the one for
cost?
Going by
Excel costs.
Excel cost. Okay.
Yes. Right. Then we'll confirm and scroll to the end. Click on the tab and make sure there is estimating on it. After optimization, and after those financial Okay, you can take a look at the chat. Somebody say something that he doesn't have something.
Okay.
You can just upload it there also. And if you try to upload it, it's not opening, then you have to close your own. I think I tried it last time. If your Excel is open and you're trying to upload the same thing on, it will not open.
If you don't have, check either your inbox or your spam. You must have it. We took time to send it to everybody.
Well, I have here cost for Excel. Is that the same as the Excel cost you're talking about?
Yes.
So which way am I scrolling? I can see so many tabs.
Yes, just go to the end. Just go to the end of the sheet.
Okay. I've reached amortization.
But at the end of the sheet, I think your own might end up in optimization. When your own end up in optimization, don't worry.
It ended up in amortization.
So in amortization, okay, don't worry. Don't worry. We'll show you what to do. Just in the next 3 minutes, we'll come back shortly.
Okay.
Hello, Engineer Sonny. Hello, Engineer Sonny.
Yes, I can hear you.
Okay. Mine ended up in scenario manager.
Check where. I don't think. Check. You may have other exec going up.
Sorry, Engineer Sonny, that might be true. Let's. I think you have to bring up this one. We do some updates. I think the person is right. Yes, we did some updates. We keep improving the thing. So you just send it through the chat. He's right, sir.
Okay.
Let me see.
to send it to the sheet. Let me see how to send. Let me send it to the chat. This thing here. Let me upload it for you. Try to upload it. I'm trying to connect you. I don't know why. Can you hear me?
Yes, we can hear you.
I'm trying to upload it. It's showing me network disconnected, but I can hear you people. I don't know what is happening. It's not showing network disconnected, but I think I can hear you people now.
Okay, maybe can it be sent after the training? And
Yes, I think after the training I will share it. It's still disconnected. Okay, I will share it after the training. So let me just call a minute. Oh, first go inside first. Okay, so let's do some. Can you see my Excel sheet?
Yes, we can see it.
Okay. Now, I just want to show you some basic way of doing a little estimate for getting the materials needed in construction work. Now, for example, if you want to carry out a building, let me say a building that is a building with this yellow, the length is 10 meters, while the width is 5 meters. And as this is slab, you want to cast the concrete for this slab. And the thickness of this slab is, let me just use for simplicity, 150 mm, which is equivalent to 0.150 meter. Now, and when you want to cast this concrete, your client will tell you that the strength of this concrete they need maybe is an M15. The strength is 15 Newton per mm square. That is the strength of the concrete. And in concrete, we have different strengths, maybe 10 Newton, 15, 20, 25. All of them have different ratio in doing it. For example, for the strength of 15, I think the ratio is 1:2 to 4. In this ratio, let me highlight it. In this ratio, what it means is that it doesn't mean one bag. Let me put cement here. Let me put sand here. It doesn't mean one bag of cement to 2 hectares of sand to 4 hectares of granite. That is not what it means. What it means is that 1 part of cement to 2 parts of granite to 2 parts of aggregate. You must use the same unit. And we know a bag of cement is 50 kg. A hectare of sand is 25 kg. And a hectare of granite is also 25 kg. Now, you want to cast this slab. You want to cast this slab. And you want to know how many bags of cement am I going to use to cast this slab? How many hectares of sand or tonnage of sand will I use to cast this slab? And what is the tonnage of aggregate I will use in casting this slab? So you will want to know all this. But how can you not know them? So what we want to tell you now is, for if you are missing this material, you are using a concrete. Your concrete is wet. Concrete is a wet material. But the material that is giving you the concrete is a dry material. So we have a ratio of dry concrete to wet concrete. The ratio of dry concrete, the ratio of wet concrete to dry concrete is equals to 1.54. It's constant. It means that to get your weight of concrete, you have to multiply by 1.54 to get multiply it 1.54 times the dry weight of the concrete before you can get the weight of the concrete. Now, if I want to really get the numbers of bag of cement I will use, that of sand I will use, that of granite I will use, the first thing I need to do is to add up all this ratio, because we are using ratio 1, 2, 3, 4. If I add up that ratio is automatically 7 for me. Then for me to now get for concrete, if you want to do it, you will do it for one. If I want to calculate the volume of this slab, the volume of this slab will be equal to 10 the length times the 5 the width times the thickness 0.15 is 7.5 cubic meter. That is the weight. That is the volume of the slab. Now, but if you want to calculate the material here, you calculate for 1 cubic meter. 1 cubic meter. Now, let's start with concrete. Let's start with cement. What is the ratio of cement here? The ratio of cement here is 1. What is the total ratio? 7. So what we do, it will give you equals to ratio of cement divided by the total ratio. You will get the ratio. So to now get the volume of cement, will now give you this ratio of cement multiplied by this constant factor, which is the ratio of wet concrete to dry concrete. This 1.54. When you divide, this will give you the volume of concrete in cubic meter. And we know that in our normal elementary math, we know that. Okay, I told you just now that this one, the yellow one, is the concrete is a wet material, but the cement, sand, and aggregate for producing the concrete, they are dry materials. Because of that, there is a ratio of wet concrete to the weight of the dry material in producing them. So the ratio of wet concrete to the dry material, dry concrete, is 1.54. It's a constant ratio. It's a formula that has been discovered, and it's a ratio like that. Now, if you want to, I'm not saying before you will do it for 1 cubic meter. Always do it for 1 cubic meter before you multiply everything. Now, for cement, if you are considering cement, what is the ratio of cement here? 1. The total ratio is 7. So the cement now, the ratio of cement would not be 1 divided by 7. That is where we have this one. Now, to get the volume of cement, we multiply this ratio by this 1.54. That is where we get this volume. That is the volume. And remember, we know that density is equal to mass over volume. Density is equal to mass over volume. And what we are looking for is the mass. Then in such a case, mass is equal to density times volume. And density of cement is 1440 kg cubic meter. Then to not get the mass of cement will not be equal to volume times density. We are having 317 kg. But we know that what we are looking for a bag of cement. A bag of cement is 50 kg. To now know the numbers of bag of cement you will use, you will use for this 1 cubic meter will now be equals to the total kg, which is the mass, divided by unit mass of a bag of cement. When you divide, you are going to have almost 6.5 bags. If you are not casting this slab, the total volume of this slab is 7.5. But this value we have is per cubic meter. So to not get the total bag of cement, you now multiply this number by this 7.5. You are now getting almost 78 bags of cement. So 78 bags of cement is what you will use in constructing this concrete slab. So the next thing, we go to the sand. In sand, the ratio of sand is equals to the ratio of sand 2 divided by total ratio. It'll give you that. Now, the volume of sand is equals to this times the units, 1.54. Now, as usual, density of sand, we have different categories of sand. We have sharp sand, we have wet sand, but the density of sand ranges from 1,400 to around 1,500. So for wet sand or sharp sand is 1,450 density, kg per cubic meter. Now, to not get the volume, to not get the mass of sand is equal to density times volume. Or this density times volume is giving you 638 kg. And we know in a pound of sand, you can get it in a pound or you get it in tonnage. If it is a pound is 25 kg. To not get
No more connection.
This is shower. Yeah, I think there's a small challenge. Jason is having small challenge, but we'll soon be back. Just exercise patient, please.
Hello, Uche. Hello, Uche.
Yeah, I can hear you, sir. I can hear you.
Give me permission to share.
Okay, sir. Okay, sir. There you go.
Okay. Okay. Sorry for that. Is network failure. So what we just ended here. So when we now have the numbers of headpans for 1 cubic meter, what we do to get the total for the whole slab, we now multiply that for the total volume of slab, which is 7.5. We are having about 191 headpans of sand. You can as well convert it to tonnage, which can also just give you this divided by 1,000. You are having 6.5 kg, 6.5 tons of granite. So the same thing is applicable to ground aggregate or granite. So the volume, the ratio volume is the 4 divided by 7. They're having it. Then the volume will be this, the ratio times the constant 1.54. Then the density of aggregate is 1,500. Then the mass will now be equals to density multiplied by volume. You're having it. And granite is normally reported in tonnage. So if you just divide, this is for 1, then for all, you just this times 7.5, which is the volume of the slab. You have this. So when you divide this by 1,000, you have about 10 tons of granite to be used. So this is how you can calculate the quantities of materials that make up the concrete. In case somebody wants to build a house for you, is the bag of cement, sand, and granite. You should be able to have the basic knowledge. Also, if you want to calculate the numbers of blocks for a wall, if you have a wall that, assuming this is the height of this wall, and this is the length of this wall, the area will now be equal to 10 meters the length times the height, which is 5. Is giving you 50 square meters. So if you multiply 50 by 10, you are having 500. So for this wall, the numbers of blocks needed to construct this wall is 500 blocks. A square meter of wall is equivalent to 10 numbers of blocks. So when you calculate the area, just multiply by 10, then you get the numbers of blocks for that wall. So another thing I will tell you again, I'll just show you before we go to, normally in water cement ratio, we normally use 0.54 for water cement ratio, or approximately, or maybe 0.5. And that is the reason why the ratio of this wet concrete to dry concrete increased by 0.54. Or somebody just raised the question on the chat. That is why the ratio of wet concrete to dry concrete increased by 0.54. That is the volume of water, the water cement ratio. Now, another thing, if you want to use reinforcement for this slab, and maybe you would put a reinforcement vertically like this, you put the reinforcement horizontally like this. And at the end of the day, you measure all the length of the rod you are going to put on the slab from the bar bedding schedule for those who are civil engineers. And you now arrive at 800 meter length of rods. 800 meter length of rods. how will you know the tonnage of reinforcement you are going to use there? In reinforcement, we have 10 mm. I think we even have 8 mm. We have 12 mm. We have 14 mm. We have 16 mm, and we have I think 20 and maybe 25. So in all, if you measure the length of the reinforcement you are going to use here, and it's giving you 800, and the question is, what is the tonnage of reinforcement you need for this lab? What you will do, you will calculate the weight per unit meter, weight per meter runs of the rods. Considering 8 mm rods, what I will do, it will now be equal to network failure. I'm back again. I hope you can hear me.
Yes, go ahead. I can hear you.
Okay. So to now get the reinforcement for each of them, it will now be 8 square, 8 square, where is my square? My 8 square divided by 162 is giving me this. If I have this one will give me, I think if I have, let me just say, if I have 162 here, and I will just say 8 square divided by 162, 8 square divided by 162 equals to 8 square divided by 162, and I will fix this 162 because it's constant for all of them. I will fix it by using dollar sign. I will get this. So if I just draw that, I should have calculated for the other ones. Oh, no. I'm not supposed to fish. But anyway, if I want to do the one for this, I will say.
I think the dollar sign should be on the cell on both the letter and the alphabet.
Okay, and I think because there's a gap. No, it's because I did not refresh it. I typed it myself. I did not refresh it. I will say
yes.
I will say 8 raised to power 2 divided by this. Then I will fish it.
$13.
Yeah, I will fish it. I will do it like this. So if I draw it down, I will calculate for the remaining one. So this is how you get it. Hello? Yes, it's correct now. What it means, multiply 10 squared divided by 162, 12 squared divided by 162, 16 squared divided by 162, 20 squared divided by 162. It means that if you are using a 12 mm rod for the reinforcement, the unit weight per meter runs is 0.88. So what it means is that if this reinforcement we have here is 12 mm rods, and the total meter is 800. If I want to get the tonnage of reinforcement needed for this lab, it will automatically just be 800 times this unit. It will give me 177 kg. So that is the tonnage of reinforcement you need for this reinforcement. So that is how to calculate basic reinforcement and basic material in estimating. So at this time, we are going to the main work of today, which is project cost control. And that is the major work of today. Let me share the slides. Are you seeing these slides?
We are seeing it, sir.
Can you see the new slide? Okay.
Yes.
This project progress and performance measurement for project control. I think you see.
Excuse me, engineer. I'm sorry to cut in.
Okay.
In the last calculation, we're trying to find out where the connection was poor, so we didn't hear where you got the 162. Is that a constant?
Okay. Yeah, the 162 is a constant. Let me come in. I'm coming. Let me bring out the Excel sheet again. Are you a QS?
No, I'm just a curious chemical engineer.
Hello. Okay, it's a constant because why I asked you whether you are a QS is that in QS has another big formula they use in calculating their O. So when in one of the class, I said this is the formula we use in engineering. It's just the whole formula is a big one. So we not summarize everything to the lowest level. It will not leave everything as a function of the diameter of the reinforcement. So everything is just a function of the diameter. 162 is constant. So then I said, no, they have another big formula they use with QS. And I said, okay, let's apply the formulas. We both applied the formula and we got the same answer. Then I said, instead, if we can use this simple formula to get the same answer, there's no need for cramming their big formula. So they will continue to adopt this small formula. This is 162 is a big formula that has been rationalized to the lowest level, and only this singular formula now come out from it. So everything is now a function of the diameter. So if the diameter is 8 mm, just multiply it 8 squared divided by 162. If it is 10 mm, 10 squared divided by 162. If it is 12, 12 squared divided by 162. That is how it's calculated. I hope it's clarified. So let's go back to the control. Now, we want to talk about project progress.
Hello, sorry, engineer, to pick you back. I'm sorry.
Okay.
Please, I want to ask where is it? Please, can you go back to that Excel?
Okay. Can you see it now?
No, it's not. Okay, yeah, the 711. What is it for? How did you get the 7100? 711.
This 711, we said that when we carry out the reinforcement, let's say all the reinforcement that we have put on this slab, when we measure their length, the total length of the reinforcement is 800 meters. We assume it. And we now said, assuming the reinforcement is also 12 mm rods. So to not get the total tonnage of reinforcement we will use here, it will not be equal to the total length of reinforcement multiplied by the unit weight of 12 mm rods. This is the unit weight multiplied by this. You will not get the 711.
Okay.
That's where we go. Yeah. Okay, thank you, sir. Now we go to the project cost control for today. So are you seeing my screen?
Yes, we are seeing it. Go ahead.
Okay. Now we want to talk about project progress and performance measurement for project control. And at this session, you just pay an attention so that at the end of the day, you should be able to carry out a cost control on any project. I will move you through the slides, then maybe that will take us to around 5 o'clock. Then we will now take a 5 minutes break. We come back to the exercise to see how we can get all the whole exercise. Now, in project life cycle costing, we have 5 steps: project initiation, project planning, project execution, monitoring and control, closure. On this slide, we are focusing our attention on monitoring and control. I put this just common because we have already dealt with this on the first day. We already treated this one justly, estimate cost, contingency reserve. Now, I will want to enter project monitoring and control. If you are a PAP certified or you have been involved in projects, there is project monitoring and control. Some people seem not to understand the difference between monitoring and control. Monitoring and control, they are not the same thing. They differ. So project monitoring is a process base. You are looking at the process you are following to make sure you are in order. That is monitoring. Project control is result based. You are looking at the result. We said we are going to spend 5 hours doing this work. Is it 5 hours we are actually spending? That is control. We said we are going to spend 2 million in constructing this bridge. Is it 2 million we are actually spending? That is control. But the process we follow to ensure we construct the building is what we call monitoring. If you are trying to audit the process, that is called monitoring. That is why you see sometimes you see ISO 9001 for quality management system. When you are auditing the quality management system of the company, you are looking at the process. That is monitoring. They are all ISO based. But when you are talking about control, they are project based. And the one we are particular about today in the course of this module is project control, which is result based. Now, and project progress and performance measurement are the 2 components of project control. Progress and performance are the 2 components of project control. Why project control? Why do we need to control projects? It's not even only project in anything. Because we want to track the time, because we want to track the money. Are we spending money as planned? Are we spending time as planned? It's not only related to only projects. Well, let me say everything can be in operation. A project is any temporary endeavor that has a start time and a finish time. It must not be construction. It must not be manufacturing. You can use it during burial. You can use it during marriage. When I did the burial of my mother, I applied cost control. And at the end of the day, the variation was not all to plus or minus 5%. But when I did my wedding before the burial, there was no
Is what's happening?
Hello, can you hear me?
I can hear you. Just I can hear you. Shh, shh. Hello?
Okay, give me
I don't know what's
permission to
happening.
share.
Is it the network? What type of network are you using?
This network, the weather here is very dull.
Yeah, I can see. I can sense that.
Give me permission to share.
Okay, sir.
Okay. Can you see my screen?
Yes. We can see the screen.
Okay. Okay. Now, progress means how far are we to where we need to go. Assuming you are in Abuja and you want to move to Benin, and the total distance is 200 meters. But as at the point of trying to know where you are in Kogi, 130 meters. Your progress so far is to date divided by total, which is 130 meters by 200 meters is equal to 65%. So based on this, you have progressed 65% so far. If there is only one thing to do, if we just have only one measurement from A to B, then it's very easy for us. Measuring progress will be very easy. When there are thousands of things to do, measuring progress becomes a logistic challenging. Tedious manual work or software needs to become necessary. So why we are saying here is that it's just because it's just A to B, we just measure it, and because of that, we said it's just a progress. But there are times progress might be very cumbersome and very tasking. Let's go to the next one. There are different methods of measuring progress. You can use a milestone base. A milestone is if I achieve so task, I will earn so credits. That is on milestone basis. Who can tell me what is a milestone? Unmute yourself.
Well, any aspect of the works that you've completed payments can be made for, can be considered a milestone.
Okay, that is very perfect. What duration do you assign to a milestone?
No duration. The duration depends on the total duration assigned to the project.
The milestone event has 0 duration.
Hello? Hello, Uche.
Yeah, I can hear you. I've done
Okay,
it. Don't worry.
okay.
I've done it.
First, network is bad, but I hope in the next 30 minutes we should be able to finish for today. So I was asking somebody just now, what duration do we assign to a milestone?
It depends on the total duration assigned to the project as a whole. The milestone is only a fraction of the project. So the duration will also be a fraction of the time assigned to the total project.
And somebody said to me that a milestone has 0 duration. Yes. So the person who answered this question is very correct. A milestone has a 0 duration. A milestone has no duration. The duration of a milestone is not the sum of all the duration of the activity making up the milestone. A milestone is just a point in time at which an important task has been achieved. So one thing you will know is, because it's very common in project management exam and in CCP, one thing you should know about milestone is that milestone has no duration, milestone has no resources, milestone has no resources attached. Now, we also know that another method for measuring progress is weighted methods. We will discuss all this in the course of this lecture. It can also, in this case, that is why we said we recommend CCP for you people. In that case, we discuss a lot of statistical methods where you can distribute costs, where you can distribute your costs based on weight. Then we also have an hour base. Based on the hours of work done, you can measure your progress. We can also use a value of work done, VOD, to measure your work. And we can also use activity-based and schedule-based. But you will see there when we are doing the application. Now, let's see this. Because progress just now is because the one we did just a one item, it was just very easy for us because we just measure the length and divide by the other one. But what of when the progress has a mix of units? Look at this. We have concrete and steel as a mixed unit. How can you measure the progress between concrete and steel? Concrete is a cubic meter, steel is a tonnage. How can you now measure the progress? So in such a case, you have to consider the amount of effort to complete the work, which is hour. That is why I said yesterday, in EPC project, in construction, the common factor is job hour. In engineering, the common factor is job hour. But in procurement, the common factor is job cost. Let's see this. Now, this is the total hours of work you want to work, 4,300. To date, you have worked 3,800. Progress will be what you have done to date divided by the total, which is B divided by A. You are getting 88% complete. Also, if we want to work for 12 hours of work, if we are working for 12 hours, we can easily measure the total work by the 4,300 times 12. We are getting this. We also multiply what we have achieved to date times the duration. We are getting this. By the time we divide what we have earned divided by this, we are getting 88. Everything is 3 hours. Now let's move further. This is a surprising case. We have activity here. We have concrete in cubic meter, steel in tonnage, piping in meter, mechanical equipment each, electrical cable in meter, termination each. And these are the quantity to be installed. These are the quantity you have to be installed. But to date, you have installed all this. To measure progress for each of the activity is what you have installed to date divided by the total. This divided by this, you get this. This divided by this, you get this. This divided by this, you get this. But the question I will ask, if I should ask you what is the overall progress, what will you tell me? If I add all this total work together and get this, and add all these total together and get this, if I divide this by this, it's going to give me 80%. The question is 80% not the overall progress? No, because it is not a common factor. All these ones have different units. All these ones have different units. Before you can call it a progress as a singular figure, all of them must have the same unit. So hour is the common factor in construction work. Let's go to the next slide. Now, based on the work we have here, we want to multiply by 12 hours. When we multiply all these one by their various hours, we get these are the total hours you need to work. This is where the weighted average method comes into. When you get the total hours of work you want to work, all of them are now in the same unit, hours. Add all the whole hours together, you are having these total hours. To get their individual weight, divide their individual hour by the total hours. Always read the heading, you see how I develop it. It's now this divided by this, you get 30%. This divided by this, you get 40%. You do it, you get their corresponding percent. But so far, this is the total hours you have earned. So if you divide these total hours by their original hours, you are having 40%. Total hours, hours earned divided by total hours, you are getting their corresponding percentage progress. When you have this percentage progress and you have this weight, to get the overall percentage, contributing percentage, you will now begin to multiply the weighted percentage by the contributing percentage. The weight percentage multiplied by the progress percentage. When you multiply this by this, you are going to have 12%, 4%, 8%, 9%, 18%, 2%. But when you add everything together, you are going to have 42%. If I still come here, if I add up all these total hours together, I will have this. If I add up all these total hours together, I will have this. If I still divide this by this, I will still have 42%. So overall progress will now be 42%, which is here summation of all the total summation of all the end hours, this divided by the summation of all the total hours, and which is still equals to the summation of all the contributing factors. So you should know this, how to measure progress when you have a mix of units. Now, if you now have an EPC project, you have an engineering session, you have procurement session, you have construction session, and the total budget for engineering is 263 million. The one for procurement is 788 million. The one for construction is 700 million. And you have their weight, corresponding weight, and you have their progress. So when you multiply the weight by progress, you are getting their contributing percentage. When you add everything together, you are going to have 59%. Overall, you are having 59%. But on individual session, you have 40% engineering, 28% procurement, and 70% construction in progress. Now, let's go to performance. That is everything about progress. But what is performance? Just now we said that progress is how far are we to where we need to go. The performance is how well have we done against what we planned. You remember the slogan, it is not how far, it is how well. That how far is the progress, how well is the performance. Performance is N over actual. In project performance measurement using N value measurement, we have 3 performance metrics or KPIs in measuring performance. We have the baseline metrics, we have the status metrics, and we have the forecast metrics. The baseline metrics is what you use in baselining your project. You set it as a benchmark. This is what I have before you give out the plan to contractors. That is what you use in developing your work plan. In the baseline metrics, we have what we call budget at completions. We have what we call schedule at completion. We have what we call planned value. we have what we call end value, we have what we call actual costs. Now, in the other one is the status matrix. The status matrix is that based on what we plan to do, based on the baseline matrix, we have given the work plan to the contractor, and now the work is going on. When the work is not going on, the next thing you want to know, how far is the work going on? How well is the work going on? That is the status of the project. The work is not ongoing. In status matrix, we have two types of status matrix. We have time status and we have cost status. The time status is the how far progress. The cost status is the how well performance. On that time status, we have schedule variance. We have schedule performance index. We have time variance. We have percentage work complete. On that cost status, we have the cost variance. We have the cost performance index. I will be showing you calculation based on this shortly. Now, the next one, I hope you can still hear me, because some people are saying network.
Yes, we can hear you.
Okay. After the status matrix now tells you this is the status of this work. This is the progress so far. This is the performance so far. From there, you cannot draw a conclusion on how the project is going to end. Is it going to end well? Is it going to end as planned? That is where you will not come out with the forecast matrix. In the forecast matrix, you will not discuss the estimate at completion, the estimate to complete, variance at completion, estimate, time estimate to complete, time estimate at completion, time estimate to complete, time variance at completion to complete performance index. When you know all these things, at the end, you will be able to develop what we call an S-curve. And you cannot use an S-curve to interpret your results and send them for reporting. At this point, we end the theory of cost control. Then let's go to the application. At this point, I will give us like 5 minutes to move around. Then we come back by 5:15. By 5:15, we start. I think in the next 20 or 30 minutes, we should be able to finish the last exercise for the cost control. Thank you very much. Okay, are we back? Are we back?
Yes, I'm back.
Okay, let's continue. Can you see my Excel sheet?
Yeah, we can see it. We can
Okay,
see it.
I think most of you have another Excel sheet somehow called EVM. Maybe most of you have another Excel sheet called EVM, which is end value management. But some of you have this full one I'm using. But I think I will still, let me still try with this internet now, whether it will work this time. Let me just check now if I can share it now. It's still disconnected. I don't know why. Maybe I don't know. Is it because I'm using it? So now, what I will do, let me make a copy
It's
of
because, Engineer Sunday, it's because you're using it.
Okay.
Make a copy of it. Once you're using it, it will not attach.
Okay.
Close it and then send it.
Let me see what to do.
Save it differently. I think you have to close it. If you send it, you now open it again.
Let me see where I can. That was 25. Okay, it's attaching now.
But does that mean the participants will
You
get
can
it?
see it there as yes, everybody on this platform can see it now. It's already uploaded. You can see it. Course practice sheet under the chat box. You can just download from there. So I have to open it again. Okay. Now let me share my screen. Okay. So when you open your that Excel sheet, so everybody, you now have the complete material now. So the whole Excel sheet, this is the only Excel sheet you will be using. Everything are here. So now,
sorry, we don't. Sorry to cut you short. We don't have it yet.
I think it's uploaded already. Check the chat box. It shows to me here successful.
It's not here yet.
Uche, can you confirm?
Hello, we have it. It's on the chat platform.
Okay. Okay. Thank you very much. Okay. Now, so you cannot see my Excel sheet. So just move down to the end of it. Even thank God the one I just used now under this estimating is there for you. So just come to this EVM, the almost second to the last. So when I get there, I want to make a copy of it so that I will not override this. I will just make a copy to the end. Okay, I'm working on this now. So I will delete, let me just delete this. All these quantity of concrete and everything I was explaining to you just now, this is where I did the exact calculation sheet, so you can do it. So now let's see what we have for today. Let's see what we have for today. Now, let me delete here. Just delete the one I deleted, you can delete it. Okay, this example I want to show to you now is a small case study. So based on this case study, you'll be able to understand everything about cost control. Now, the question is, a man wants to fence a wall. A man wants to fence a wall. A man wants to fence a wall. So what we are trying to do here is that a man wants to fence a wall. This is the wall. This is the wall. A man wants to fence a wall. This is the wall. The wall is 10 meter length. The wall is 10 meter long. This is the length, 10 meter long. And it's going to need 5 days to complete the wall. Based on the work, it's supposed to be, this is the first day, this is the second day. Let me delete this also. This is the first day, this is the second day, this is the third day, this is the fourth day, this is the fifth day. And if we have what we call any rules, any metric, what you plan to use for your work. A man that has 10 meter length of work, and the man needs 5 days to do it, the man can conveniently be doing 2 meter length of work every day. That is the planning rule. So 2 meter length every day. So on the first day, the man will construct 2 meters. On the second day, 2 meters. On the third day, 2 meters. On the fourth day, 2 meters. On the fifth day, 2 meters. At the end, the man will construct the 10 meters for the 5 days. The duration of the project is 5 days. Now, based on this work, the total budget available for this work is 20,000 naira. This is the 20,000 naira. So the total duration to complete the work, which is 5 days, is what we call schedule at completion. We are in the baseline metrics now. The baseline metrics are the parameters you bring out that will enable you to determine the status metrics, and the status metrics will now help you to determine the forecast metrics. Now, this 5 days plan is what we call schedule at completion. What did you schedule at completion is 5 days to finish the work. Now, the total budget to finish this work is 20,000. This 20,000 is what we call budget at completion. Now, if we budget 20,000 to finish the work, and we are doing 20 meters every day, and we have 2 meters, we are likely to be spending 4,000 naira every day for the project. That 4,000 naira for 5 days will give you the 20,000 naira. So progress must always be measured at a specific time, and performance must always be measured at a specific time. There must be a time base of measuring them. Now, this is what you plan. The work is 2 meters every day. The work is going to take 5 days. The cost is 20,000. You should be spending 4,000 naira every day. And this work plan was given to the contractor and demobilized to site. This work plan was given to the contractor and demobilized to site. The work was going on. On the third day, that is why I put here now. On the third day, This is the first day, second day, third day. On the third day, there was a joint valuation between the cost engineers and the QS that go to site, go and value the work that has been done. From there, we can understand the progress and the performance of the work to date. They went to site, and when they got to site, they took their ruler and they begin to measure the length of work that has been completed on the third day. When they measure the length of work, they discover that 5 meter length of work has been completed to date. Based on our schedule, what is the monetary value of 5 meter length of work? Who can give me that answer? If we are doing 2 meter per day, and it's costing for 4,000, and we have completed 5 meter, what is the monetary value of that 5 meter that has been completed?
10,000.
10,000.
Okay. Correct. It's 10,000. So that 10,000 naira is what you call your end value, what you have earned to date. That 10,000 is what we call end value. But based on the way you plan your work, how many meters of road of work are you supposed to construct on the third day?
6.
6 meters.
6 meters. Fine. What is the monetary value of that 6 meters?
12,000.
12,000.
Correct. That 12,000 is what we call the planned value as planned. So you can understand the difference between planned value and end value now. Now, the actual cost is when the contractor was asked, how much have you actually spent so far? The guy said, but if I bring out all the receipt and everything, the total amount of money I have spent so far is 15,000 based on invoice. Based on invoice, the amount of money that was spent is the actual cost. That is the difference between the planned value, the monetary value of the time frame as planned, the air value, the monetary value of the actual work that has been done. Then the actual cost is the monetary value of the invoice that has been spent so far. These are the baseline metrics. These are what the QS and the cost engineers, whosoever, collected from site, from their valuation, and they come to the office. So this thing doesn't make sense to anybody. What the management is interested in is how far, how well are we spending money as planned? Are we progressing as planned? That is what they want. And that is where the cost controller or the cost engineer will now come in and determine the status of the work. Based on that, we will come to the status metrics. And I told you just now that status metrics can be time-based and it can be cost-based. These ones are, these blue ones are the time-based, while these yellow ones are the cost-based. Now, the question that will now come before us, the first one is, the management will want to know, based as we plan on time status, what is now the schedule variance? Based on what we plan and where we are today, what is the variation? What is the variation based on time? Schedule variance is F value minus planned value. Our F value you will not come here. You will not come here. You will not see F value. What is your F value? 10,000 minus your planned value. Your planned value is 12,000. To be okay. It's minus 2,000. When schedule variance is negative, it means you are behind schedule. When schedule variance is equals to 0, it means you are on schedule as planned. When schedule variance is positive, it means you are moving faster, you are ahead of schedule. In this our work, we are behind schedule, which we can easily detect that we are supposed to construct 6-meter length of work on the third day. But so far, we have constructed only 5 meters. We are actually behind schedule. The next one, you will now determine the schedule performance index. The schedule performance index is N value divided by plant value. It will not come here. It will not be your N value divided by your plant value. Is 0.83. What does it mean? If I convert it to percentage, it means that where you are supposed to where you are supposed to be moving, you are progressing at the rate of 83%. Where you are supposed to be progressing at 100% schedule, you are not progressing at 83%. When your schedule performance index is less than 1, you are behind schedule. When it is exactly 1, you are on schedule. When it is above 1, you are ahead of schedule. It means that as planned 100% efficiency, you are moving at the rate of 83%, which actually shows you are behind schedule. Now that you are behind schedule, the question that will arise, we know you are behind schedule. How many days are you lagging behind? That is where you will now come for time variance. Time variance is schedule variance. Your schedule variance is what? 200 multiplied by schedule at completion. Schedule at completion is 5 days divided by budget at completion. Budget at completion is 220,000. It's giving you minus 0.5. It means you are lagging behind half a day. When it is negative, you are lagging behind. When it is positive, you are ahead. It means you are lagging behind half a day, which is evidence here. If on the third day, we are supposed to complete 2-meter length of road. It means that we only completed 1 meter, which was added to these other 2 4 meters that give us the 5 meter. It means that in this 2 meter, you are lagging behind half a day here. Now, the next question is, at what percentage are you working? What is the percentage of work complete? What is the percentage work complete? This is the percentage work complete. Percentage work complete is N value divided by budget at completion. Budget at 20,000. You have 50%. So far, you have completed 50% of your work, which is evidence here. If we have 10-meter length of roads to be constructed, and so far you have completed 5 meters, it means you have done half of the work, which is the 50% work complete. The blue one is the time status. We will now move to the cost status. The cost status, which is the yellow one. So the cost status now shows that the first thing for the cost status is, what is the cost variance? The cost variance is as planned and as we have spent. Is there any variation? So the cost variance is equal to N value minus actual cost. It's giving you minus 5%. Please take note here. When your cost variance is negative, it means you are over budgeting. It means you are overspending money. When your cost variance is negative, it means you are over budgeting, you are overspending. When it is 0, it means you are spending as planned, you are on budget. When it is positive, it means you are underspending, you are under budgeting. Let's see what it means. Now, the next one is the cost performance index. Cost performance index is N value divided by actual cost, which is 0.67. What it means in naira form is that for every 1 naira you are spending, you are getting 67 kobo back your value of work done. You are spending 1 naira. The value of work you are getting in return is 67 kobo. Are you not actually overspending? You are overspending. If I relate it to percentage, it means that where you are spending money at 100%, the value of work you are getting back is 67%. It means that you are overspending money. What it means is that you are supposed to be spending 67% as against what you are doing. That is why we said when it is negative, you are overspending. When it is positive, you are underspending. When it is zero, you are on budget. Now that we are not through with the forecast, with the status metrics, management will now say, okay, fine. We understand that we are behind schedule. We understand we are spending money, we have spent enough. The remaining money for us, out of the 20,000 that is budgeted, we have spent 50,000 so far. And we have done only 5 meter length of road. Automatically, the remaining 5,000 will not be enough to finish the work. The question is that, what can we do now? What can we are now behind this schedule. When you are doing a project and you are behind schedule, there are 2 ways to bring the project to normalcy. It's either you crash or you fast track. Project crashing means you are now involving, you are now bringing in more resources to join the work to finish on time. Project fast tracking means that you are not doing work, the work especially on the critical part, you are not doing them in parallel. You are not doing them simultaneously at the same time. When you are crashing your project, bringing in more resources to finish the work, the main disadvantage you will face is that is going to increase the cost of the project. When you are fast tracking and you are not doing work correctly, there is tendency that the quality of the work will be very poor. Now, the question management will now say, how much do we now need based on the way we are coming? The money that is remaining will not be enough to finish this work. How much do we now need to finish this work? There are 3 ways of doing that. That is what we now call estimate at completion. The first step there is that management can just decide to say, okay, from now we have stopped the work. What we can only do, we give additional 4,000 naira to the money. When management decides to give additional 4,000, the total budget of the total budget for the work, maybe the management decides to give additional 5,000. The total budget for the work will now be 25,000 naira as against the original 20,000 naira. That is one step. The question is that the 5,000 naira management just give like that. Will it still be enough? Another option is for management to close down phase of the work and re-estimate the remaining work. In such a case, the new estimate will not be the actual cost, the money you have spent so far, plus the remaining estimate. Plus the remaining estimate. You get the actual cost to finish. But the best way to do it is to assume that, okay, we have spent so far, but let us assume that the way we have been coming from the beginning, that is the way we are still going to end. Let us move at that efficiency. Let us move at that performance. Let us progress at that rate. Let us perform at that rate. In such a case, the estimate at completion means when you finally finish the work, how much does it cost? That estimate of completion based on the way we are coming is budget at completion divided by cost performance index. In such a case, I will divide my budget at completion, which is 20,000, divided by cost performance index. Cost performance index is what? This. Meaning that when you finally finish the work, the project will cost you 30,000 as against 20,000 originally planned. The other question is, how much do we now need to complete the project? If we have 30,000 to finish the work eventually, and we have already spent 15,000 for our actual cost, the remaining one will be estimate at completion minus what has spent already, which will now give you 30,000 minus the 50,000, which will now be the 50,000. The other question is, what is the cost variance at completion? When you finally finish the work against what was originally planned, what is the differences in the cost? The differences in the cost will not be what was originally planned, 20,000, minus what we end up with, 30,000. It will give you, no. What was originally planned, 20,000, minus what we end up with, 10,000. You can say is showing bracket. That bracket is telling you it's a negative value. That negative meaning that you overspent extra 10,000 naira. The next question that will come is that time estimate at completion. When you finally finish this work, originally we planned 5 days to finish this work. When you now finally finish the work, how many days do you now spend? The day is schedule at completion divided by schedule performance index, which will now give you schedule at completion 5 days divided by schedule performance index, which is this. It's giving you 6 days. What it means is that you can see that we assume that the rate at which we have been progressing is the rate at which we are going to end. You cannot see that in the first set, we lost half a day. In the second phase, we also lost half a day. When we add half, we are losing altogether. We have spent 3 days so far. We are spending another 3 days, which will not give us 6 days. But if I want to calculate the time variance at completion, when we finally finish the work, what is the time variation? The time variation will not be the time you originally planned, 5 days, minus the time you end up with, 6 days, is giving you half a day. It means you lost 1 day for the whole project duration. Meaning for the phase 1, you lost half a day. For the second day, you lost half a day. They will not ask you, what is the time estimate to complete? How many days do you need to finish the work from where we are today? You know that we are already on the 3rd day when we carry out this valuation. So to get the time remaining is the time to finish minus the time that has already been spent, which is the 3 days, to give you the 3. The final one is, how do you now end up with, based on the cost performance index? This one is called to complete performance index. To complete performance index is this formula. Budget at completion minus end value divided by budget at completion minus actual cost. What this formula really means to you is that this numerator means the amount of work, that the monetary value or the amount of work that is remaining, while the denominator means the monetary value of the funds that is remaining. So under exam, they may not bring this formula like this. They will give you the work remaining, they will give you the money remaining. So what you need to do to get your to complete performance index, you have to divide the work remaining divided by the money remaining. So what does it mean? It means that based on the available constraint you are seeing, if you still want to constrain yourself to the available time you have to finish, what is the time to complete? So if you carry out the valuation, you are going to have 2 days. What is telling you is that as originally planned, you need to double your efforts to finish this work. That is what it means. You have to double your effort to finish the work, because we are not moving, we are not progressing as planned. That is all about cost performance index. From here, you should be able to get the forecast metrics, get the status metrics, and get the baseline metrics. From here, you cannot, management might not still be interested in all these figures what you just showed to the management is the S curve. So if I go back to the original one, which is this is the S curve. You just plot the S curve. The S curve is a graph of this. You can see this is the same table we have just used just now. Based on what we have done so far, we spend, based on apply, you calculate the cumulative values. The cumulative value is 4,000 for the first day, second 1,000, 8,000, 12,000, 16,000, the 20,000. Based the way the work is going on as planned, we are supposed to do 4,000 on the first day, 8,000 the second day, 12,000 the third day. But based on the money we have spent and value, on the first day we spent 8,000. On the second, on the first day we finish the whole work. Second day we finish the whole work. On the third day we did half of it, which now give us this 10,000. The actual money we need to spend on the first day we spend the 5,000. Second day we spend 5,000. Third day we spend 50,000. So if you plot a graph of this, if you plot a graph, the one I selected, you are going to have this S curve. So based on this S curve, you can easily just come here and see, okay, the yellow one is what? The yellow one is the F value. The blue one on top is the actual costs. This other one is the budget at completion. Then the brown one is the planned value. So based on this, when the end value is less than the planned value, you are behind schedule. When the amount of money you have spent, the actual cost, is more than what is planned. When AC is above PV, you are overspending. When N value is under PV, you are behind schedule. So with the S curve, management can just look at the S curve and know what is happening to the project. And that is all about what we have today, which is total cost management, project cost planning, project cost estimating, project cost budgeting, and project cost control. That is all what we have for today. So at this point, we give room for question and answer before we call it a day. Thank you very much. Uche, you can moderate the platform now.
Okay, thank you, Engineer Sunday. Let me just put my earpiece well. So
let me quickly ask a question. All these abbreviations, are they embedded in the Excel solver?
Hello?
I said the abbreviations, like what was it now? And estimate at
completion. The material we sent to you.
You said?
They are in the material we sent to you. Can you hear me?
Yeah, you said it's in the material you sent to us, eh?
Look at this material here, the one I showed to you. You can see the explanation of all the abbreviation.
Yeah, I'm asking if we are using it because you've shown us an Excel sheet. I'm asking, are some of these abbreviations already embedded in the solver?
No, because we are not using it. You have to impute it because we are not using solver. It's not solver we are using. We are using Excel, not solver. We are using normal Excel platform.
Okay.
I'm using normal Excel platform. But when you, that is why when we finish this, we recommend this because the duration, the time is not enough. That is why we recommend maybe a practical demonstration of if you really want to go into cost control, we teach you MS projects. In MS project, all these abbreviations are already embedded in MS projects. So another thing we can do for you, because the way your project look like might be different from the way my project look like. But if you have the knowledge of the formula and everything, you can use it to develop your own personal template. So that by the time you just come in, you fish in the basics. You just fish in only the basic metrics. Then all the status metrics and the forecast metrics, all of them will automatically come out from you because it's a prepared template. If you have that template already developed by yourself, because the way your project look like will be different from the project my own project. I think I have a template for myself, which if I want to do, I will only just bring out the baseline metrics. All the other information will automatically generate. Even the S-curve will automatically generate also. It's a template. And if some of you will need the template, I think at the end of this training, when we have finished certificate, I can share the template with you.
Okay. I have a question. While you were talking about evaluation of progress, you said it's better to use the common factor, to use hours.
Yes.
That's the common factor. But these hours, will they reflect exactly what is on ground? The hours may not reflect exactly, the actual work carried out. So if you are going to use that to evaluate.
Okay. Can you hear? Okay. Are you through?
Yes.
Okay. Now, do you know when you use hour as a common factor? Is when you have multiple mix-up activity with different units. Like this, the case we are doing here now, we already know the duration of the project is 5 days. 5 days is already common. That is why we use is 5 days among all of them. We are using one activity, which is the project the wall to be constructed. But has it been in the process of doing the wall? We will be considering concrete, we will be considering reinforcement, we will be considering pressing, and all of them will have the amount of work to be installed, but they will be in different units. What we will do, we will say we are going to use 5 days to finish the whole work, all of them together. How many days are we use for the concrete? We will know it. How many days are we going to use for the reinforcement? We know it. How many days are we going to use for the paint? We know it. So we will now use that hours of days to multiply the amount of work to be installed. If we use hours to multiply each of the work, everything will now be converted to hours. So we cannot compare all the hours together to solve our problem. That is when you have it. When you have a mixed unit, that is when you try to use hour and convert all of them to a singular factor, so that you can compare them together. Otherwise, you cannot compare cubic meter with tonnage of reinforcement. That is
okay.
it.
Is hours the only common factor we can use in that case?
Yes. In engineering, hours is common factor. That is why you see that a labor is normally measured in hours. Hours, man hour. In engineering, it is man hour. In construction, it is man hour. But in procurement, we use cost as a unit, as a common factor.
Okay.
Thank you, sir.
Thank you.
So any other question?
We need to remind you on that link you promised to send at the beginning.
Yes. What we will do, when we are sharing the video tomorrow and the certificates, either tomorrow or latest Monday, the video and the certificate, I will share that link also. So when you click that link, it will open as a website. So all the materials you want to purchase in Nigeria, you just click out the material, the price will come out for you. And that price is always updated every day.
Oh, thank you very much. I appreciate that kind of.
Please, Engineer Igbiki, please, it's like I lost out there. The link you said you would send about the prices thing, it's like that's what you were just concluding about. Just a reminder.
Yes, I will share the link when we are sharing the video and the certificate of this training. Then when you click the link, it's a website base. So if you want to go to reinforcement, you just go to reinforcement and click 12 mm. The unit price for tonnage, it will come out for you. Anything you want to buy, the price is there. The price is continuously updated almost every day.
Thank you very much. That's quite interesting. Thank you.
Thank you, sir. Thank you, sir.
Any other question, please, gentlemen?
Yes,
all this information will be sent to our email, please. Hello?
Hello, can you hear me?
Okay, yeah, any other question before we round up the class?
I would like to find out, like, to have the proper training on this cost control. Is that we have a module can take us through maybe later?
Yes, we have a module for it that consumes just specifically project progress measurement and performance evaluation for project control using MS projects. In that case, we just do this, then we now go into MS projects and upload all those parameters into MS projects. So all those S-curve and all those things we are doing automatically, everything will automatically be updated in MS projects. So anytime you go to site, you get any other information, you just come in, input those information, then you update your plan. Everything will be updated automatically.
It's all right. Please keep us in.
Thank you, sir.
Yeah, Engineer Sunday, thank you so much. I don't know if any of us have any other question. I know the concern is about the video and the material. Now, one thing I can guarantee is that we're not holding back anything. We're going to give all the materials. Meanwhile, I still want to encourage 1 or 2 persons that have not effected payment to please kindly do that so that we can include your name in the certificate. We are going to go through the list and then produce the certificate according to those that have paid, as well as the materials and the video. So the video, as I told you, the challenge, what the video have not been sent is that there are 2 ways you record videos. It's either you record to the cloud or you record to the system. Sometimes when you record to the system, you don't have to record twice, because if you record to the cloud, you still have to download it in your system. So Engineer Sunday has happened to record these videos in his system. So if you have to send it to us, it will be in 400 megabytes. It will be so massive. So the best option now is to put it in a central cloud system and then send us the link, just like I did with the materials. So that will be done. I can guarantee you that. Just be exercise patience, and then we'll take it off from there. Let me, on my own side, thank everyone for coming. Of course, every online training has shortcomings. We know we must admit there are some shortcomings, especially when the network was not what it should be. We will continually going to improve on that. But at the same time, I also want to tell our engineers that this has become the new normal. Zoom training, learning online, just need you to have discipline and to have the time, and also to have the commitment. This has come to stay. We used to do physical training in Lagos, in Abuja, but the way things are now, most likely the online training is going to be for a while. So once again, on that note, I want to thank everyone for coming. In the absence of any question or any observation or any reservation, I will ask Engineer Sunday to bring this meeting to a close.
I have a question.
Okay, sir. Go ahead. We're listening, sir.
Hello?
We're listening. Go ahead.
Hello?
We're listening, sir.
Hello, can you hear me?
Yeah, we can hear you, sir. I think it's from your network.
Yes, if you can see on the chat, a lot of people are... Okay. I said, if you notice on the chat, a lot of people have been complaining that they have not seen some of the Excel sheets. So I don't know if maybe during sending the videos, you can resend the materials again, once again. Hello?
Okay, we will do that.
Hello?
We will share the Excel sheet again. We will do that.
Hello? Hello?
We can hear you, sir. We're going to do that, sir. We can hear you.
Hello?
Hello?
We're hearing you. Sorry.
We can hear you. They
Can
said
anyone hear
we'll
me?
do as you said.
We can hear you, sir.
Yes, we can hear you.
not getting the Excel sheet, I don't think it's from our end. I think it's some people were not able to download it, or some people didn't. Some people didn't join from day one and day two. I am aware that we've not shared anything today. So those that joined 2 days ago, you agree with me that by now you have all the materials, except for one of the updated one, the one that just has one more tab that is missing. But as I said, I'm giving you my word. What we're trying to do is to share knowledge and as well as to build capacity of our engineers. Every material that you need to succeed in costs, in becoming a cost expert and a financial expert, it's going to be sent to you. Just have that at the back of your mind. Any other question, please?
I think I have the material. I think I have the material the engineer Sunday sent today, but the ones that was shared with, previously, I received it, but it couldn't just open the system. But the one engineer Sunday shared today was okay.
What I will say, if you have the Excel sheet I just sent just now on the chat platform, which is a cost practice sheet, you don't need any other Excel sheet, because the Excel sheet we are in 3 Excel sheets before. So I just combine all the 3 of them into one single sheet, so that you will not be looking for them in different sheets. So if you have the one I just shared just now on the chat box, just forget about the other Excel sheets you have. This one cover everything.
Sorry.
It's on the chat box.
Please, I have a question. Can I go ahead?
Go ahead, sir.
Yes.
Okay. I don't know if it's the system I'm using. I'm actually using my phone. And I have not seen anything sent through the chat box, and I don't really see any attachments. So I don't know. Is it that
is why,
kind of...
Yes, that is why that man made that suggestion, that when we are sending the video, the certificate, and the link, we will share the material again along with them, so that those who cannot access the chat forum, they can download it from there.
Yes. Because in the chat forum, I only see conversation. I don't see an attachment or any other thing.
Yes, maybe because of the phone. Yes.
Yes.
Okay. That's a good one.
Over to you. Yeah.
Gentlemen, I think in your Sunday, you're the host. I made you the host. So from my own part, I think we've been a good day. It has been a good 3 days. Apology for the shortcomings, network, and other challenges. From my own end, I want to thank everyone for coming. I don't know what you have to say, and then you end the class.
No, we really appreciate their efforts, and I just implore you to continue to practice it. Don't hold the knowledge. Just look for somebody else you can share the knowledge with, and from so doing, you will be improving in the knowledge. But by the time you keep it to yourself, so that only you will know it, you will just be forgetting. You will not know. Before you know, everything will just disappear from your brain. Just try to share knowledge. The more you are sharing knowledge, the better you understand everything.
All right.
Thank you very much. So, yes. So
thank you, everybody. Thank you for coming. We'll see you. We'll meet again.
Thank you very much.
Thank you very much.
Thank
Happy weekend. Yes.
Happy weekend and happy Sunday.
Same to you. Thank you.